in the heart of the Galactic Academy, a sprawling institution that housed the brightest minds from across the universe. A particular group of students gathered for their biology class. Unlike most classes that covered more generalized topics, this session was unique. The subject of study wasn't some newly discovered alien species or a strange microorganism from a distant planet. Today's focus was on humans' Deathworlders, as they were often referred to in the galactic community. The term Deathworlders was not given lightly. Humans came from a planet classified as a death world, a category reserved for planets that harbored extreme environmental hazards, predators, and volatile conditions. Despite this classification, humans had thrived, becoming one of the galaxy's most resilient and adaptive species. The class was led by Professor Sartal, a seasoned educator and renowned expert in comparative xenobiology. He was an imposing figure, standing tall on his three tentacle-like legs, with a long serpentine neck that swayed gently as he spoke. His skin shimmered in hues of deep blue and purple, reflecting his excitement for the upcoming lesson. Today, he planned to reveal a mystery that had perplexed even the most advanced minds in the galaxy: how and why humans burned calories at such an astonishing rate. The alien students, a diverse mix of species with varying body shapes, abilities, and intellectual capacities, were gathered around the central holo-display in the classroom. Each student came from planets that had evolved under far different conditions from Earth. Some were used to low-gravity environments, where energy expenditure was minimal, while others thrived in high-pressure atmospheres where efficiency in caloric consumption was vital for survival. None of them, however, were prepared for the enigma that was human metabolism. Professor Sartal activated the holo-display, and a 3D image of a human male appeared, rotating slowly in midair. The image depicted a typical human specimen, medium height, average build, with a muscular structure that hinted at the physicality of the species. The professor addressed the class. Today, we will explore one of the most perplexing aspects of Deathworlder biology. Sartal began, his voice resonating through the room. Humans are capable of burning calories at an extraordinary rate. To put this in perspective, the average galactic species consumes minimal energy compared to humans, and yet, these Deathworlders appear to burn through their energy reserves even when performing the simplest of tasks. There was a murmur of confusion among the students. Most of them came from species where caloric intake was carefully regulated, and excess energy expenditure was considered inefficient, if not wasteful. One student, a large insectoid being from the planet Veklar, raised a limb. "Professor, why would any species evolve to consume such vast amounts of energy? Well, wouldn't that be a disadvantage in the long run?" Professor Sartal nodded thoughtfully. "An excellent question. For most species, conserving energy is indeed the key to survival. But humans coming from a death world evolved under constant environmental pressure. They are required to move, adapt, and respond to threats on a near constant basis. Their metabolism reflects this need." To illustrate his point, the professor summoned a live feed to the holo display. It showed a group of human students in the Academy's recreational facility. They were engaging in what humans called exercise. The aliens watched, intrigued, as the humans ran on treadmills, lifted weights, and performed exercises that pushed their bodies to the limit. To most galactic species, such activity would be considered excessive, if not outright dangerous. Yet, here were the humans sweating and breathing heavily, expending energy at an alarming rate, and doing so voluntarily. "As you can see," continued Sartal, "these humans are not in danger. They are performing what is known as exercise, a deliberate effort to burn calories. But what's even more fascinating is that they do this on a daily basis, often for recreational purposes." The class watched in astonishment as one of the humans, a female, began sprinting on the treadmill at an incredible speed. Her muscles flexed, and beads of sweat rolled down her skin. The holo display showed her caloric burn in real time, thousands of calories evaporating with each passing minute. Humans, it seems, derive benefit from this excessive expenditure of energy. Their bodies are designed to recover rapidly and grow stronger as a result of these physical exertions, Sartal explained. But how? And more importantly, why? The professor directed the students to observe a small device attached to the human's wrist. This, he pointed out, is a calorie monitor. It tracks the energy burned during physical activity. For today's experiment, we will monitor a human subject as they go through their daily routine, and we will try to understand the mechanisms behind their incredible metabolism. The experiment began with the human subject, a male, named David, sitting calmly at a desk in the Academy library. He wasn't performing any strenuous activity, merely reading a digital book. The class watched the holo display, which showed the human's caloric burn, 80 calories in just 30 minutes. One of the students, a slim reptilian being from the low-energy planet Karis, was the first to react. "How is this possible?" He's not moving. My species barely burns 80 calories in an entire day. Professor Sartall nodded. Indeed, human bodies burn calories even at rest. This is called the basal metabolic rate, the energy required to maintain basic bodily functions, such as breathing, circulation, and brain activity. For humans, even resting burns a significant amount of calories, much more than in most galactic species. As the class observed further, the human subject got up and walked to a nearby food dispenser. The class watched as he selected what humans called a snack, a small, calorie-dense bar. He ate it quickly, and within minutes, his caloric burn rate increased. The students were perplexed. A student from the aquatic planet Lyser, whose species consumed nutrients through osmosis, asked why would he need to eat so frequently. In my species, we can go for cycles without food. Sartall smiled. Humans need to consume food regularly because their bodies are constantly using energy. But there's more to it than just their metabolism. Let's observe his next activity. David left the library and went to the gym, where he began lifting weights. The class watched in awe as his caloric burn skyrocketed, reaching hundreds of calories in just a few minutes of exercise. The human's muscles flexed and strained, sweat pouring from his body as he continued the physical exertion. His heart rate soared, and the class could see the impact on his caloric consumption in real time. Humans engage in activities that force their bodies to adapt, explained Sartall. This process not only burns calories but also builds muscle and increases strength. Their bodies are built to endure, recover, and grow stronger from these challenges. It's a survival mechanism ingrained in their evolution. As the class continued to observe, the human finished his workout and consumed more food to replenish his energy. Despite the intensity of his exercise, he appeared energized, not exhausted. This was a mystery to the alien students, who were used to conserving energy at all costs. In most species, Sartall concluded, excessive calorie burn would be detrimental. But for humans, it's the opposite. Their ability to consume and burn vast amounts of energy is what makes them one of the most resilient species in the galaxy. The students, still processing the information, couldn't help but feel a mix of awe and confusion. To them, humans seemed like an anomaly, an energy-consuming, calorie-burning mystery. And this was just the beginning of their exploration into the biology of Deathworlders. As the class processed the information presented in the first chapter, their fascination with human metabolism only deepened. The human species, which had evolved under the most hostile conditions, seemed to defy every biological law the galactic community had long taken for granted. Humans burned calories not just when they were in motion, but even when they were at rest. This alone challenged the efficiency-driven logic that governed most other species, for whom energy conservation was the highest priority. After observing the human subject's caloric burn through exercise and rest, Professor Sartall initiated the next phase of their investigation. The class was about to dive deeper into the evolutionary roots of human biology, and what they were about to learn would shock them even more than the caloric burns they had witnessed earlier. The professor activated the holo display once again. This time, it showed a detailed map of Earth Human's home planet. The map highlighted various regions of the planet, illustrating the diverse climates and environments humans had adapted to over millennia. Deserts, jungles, icy tundras, and volatile mountainous regions all blinked on the display, each more extreme than the last. While humans evolved on a planet that forced them into constant adaptation, Sartall explained. This map shows the diversity of their ecosystems, each one presenting its own set of challenges. Unlike most species, which evolved in more controlled, stable environments, humans were shaped by unpredictability. This is a key factor in why they burn calories the way they do. The class watched, transfixed, as Professor Sartall zoomed in on a particularly harsh environment, the desert. Temperatures soared to lethal levels during the day and plummeted at night. Yet humans had thrived here, learning to hunt and survive despite the hostile climate. One of the students, a slender creature from the low-temperature planet Icarus, raised its limb, glowing with curiosity. But Professor, how did humans evolve to survive in such extremes? My species would freeze in an instant if exposed to such drastic temperature changes. Sartall gave a nod, anticipating the question. That's the fascinating part. Humans evolved to be generalists, not specialists. Most species are finely tuned to a specific environment, like your own, which thrives in cold. But humans, they evolved to be able to move, to adapt to new environments. They are not restricted to any single climate or ecosystem. Their bodies can regulate temperature, increase caloric burn, and even store fat for long periods without food. This flexibility is what makes them unique. He gestured towards the holo display, which shifted to a new image. A human engaged in a long-distance run across a barren, arid landscape. The human's muscles rippled as they ran, their face focused and determined, despite the blazing heat. This is where the energy expenditure comes into play, Sartol continued. Humans didn't just evolve to survive in these environments, they evolved to move constantly within them. Whether they were hunting or fleeing from predators, their bodies needed the capacity to endure long periods of activity. This is why they burn calories even when they are at rest. Their bodies are in a perpetual state of readiness, prepared to engage in physical exertion at any moment. The class observed the runner in the simulation, watching as their heart rate increased, muscles strained, and caloric burn soared. For the alien students, whose species had evolved to preserve energy and remain as efficient as possible, this was difficult to comprehend. In their societies, excessive energy expenditure was wasteful, even dangerous. Yet here was an entire species that thrived on it. But what about when humans don't need to exert themselves? Asked another student, a pale amphibious being from the water planet Palisa. Surely there must be a cost to burning so much energy all the time. Professor Sartol nodded, his serpentine neck swaying slightly as he considered the question. There is indeed a cost. Human metabolism is a double-edged sword. While their ability to burn calories rapidly gives them an advantage in terms of strength, speed, and endurance, it also means they are constantly in need of replenishment. Without regular food intake, their energy levels plummet, and they become vulnerable. This is why humans must eat frequently compared to other species. The holo display now shifted to a human dining scene, showing people gathered around a table filled with various foods. The class watched as the humans consumed large amounts of food, quickly replenishing the energy they had lost through the day's activities. The students were astonished by the sheer quantity of food humans required. To most of them, a single meal could last for an entire planetary cycle. Yet here were humans eating multiple times a day. It's not just the quantity of food, Sartol said, continuing his lecture. Humans require a diverse range of nutrients to fuel their metabolic processes. Proteins, fats, carbohydrates, all of these are essential to maintaining their energy levels. Their bodies are complex systems designed to convert these nutrients into the energy they need to sustain their activity. The display zoomed in on the molecular structure of human metabolism, showing the intricate process by which the human body converted food into usable energy. The students watched in awe as the display broke down how sugars were transformed into glucose, which in turn fueled the human's muscles, brain, and organs. One of the students, a tall avian creature with feathers the color of emerald, raised a wing to ask a question. But what happens when a human doesn't have access to food? If they burn calories so quickly, wouldn't they eventually run out of energy? Excellent question, Sartol replied, a note of approval in his voice. Humans have evolved another mechanism to cope with food scarcity, fat storage. When food is abundant, the human body stores excess calories as fat, which can then be used as a reserve in times of famine. This is why humans can survive for extended periods without food if necessary. Their bodies will tap into these fat reserves, using them as fuel until they can find food again. The holo display showed an example of a human in a survival scenario, lost in a desert with no access to food. The human's body, initially strong and energetic, began to slow as it consumed its fat reserves. Yet, even in this weakened state, the human continued to function, albeit at a reduced capacity. The class was silent, processing the information. For many of them, the idea of storing energy as fat was foreign. Most of their species were so efficient that they didn't need to store excess energy at all. It was yet another indication of how humans had evolved to endure extreme conditions. Now Sartol said, breaking the silence, let's examine the psychological aspect of human caloric burn. Their need for constant movement, coupled with their high energy requirements, has shaped their behavior as well. The holo display shifted once again, this time showing a human city bustling with activity. People were walking, running, working, and engaging in countless tasks. The energy of the city was palpable, a constant hum of movement and productivity. Humans are not only biologically programmed to burn energy, but their entire culture revolves around it, Sartol explained. Their societies value activity, progress, and achievement. Sitting still for too long is often frowned upon, and humans are always striving to push their limits. This cultural drive is linked to their evolutionary need for movement. They feel an innate urge to expend energy, whether it's through work, exercise, or even recreation. The students watched the scene unfold, observing the endless motion of human society. It was a stark contrast to many of their own home planets, where efficiency and minimal energy expenditure were prized. For humans, it seemed energy expenditure wasn't just a biological necessity, it was a way of life. One of the students, a large, lumbering creature from a low-gravity planet, finally spoke. It's almost as if humans are designed to never stop. But what happens when they do? What happens when they can't move? Professor Sartol's expression became more serious. The That is one of the weaknesses of the human metabolism, because they are so reliant on movement and caloric intake. When they are deprived of these things, their bodies can begin to deteriorate rapidly. Long periods of inactivity can lead to physical and mental health issues. Humans must maintain a balance between activity and rest, which is why their societies have developed complex systems of healthcare and nutrition to ensure that balance is kept. The holodisplay now showed a human who had been immobilized due to injury. The students could see how the lack of movement began to take a toll on the human's body, causing muscle atrophy and decreased energy levels. It was a sobering reminder that, while humans were incredibly resilient, they were not invincible. However, Sartal concluded, despite these weaknesses, humans remain one of the most adaptable and resourceful species in the galaxy. Their ability to burn calories rapidly, combined with their psychological and cultural drive for constant improvement, has made them a force to be reckoned with. They are survivors, and their metabolism is both their greatest strength and their greatest vulnerability. The class sat in stunned silence as the holodisplay dimmed. They had learned much more than they had expected about human biology, and the implications of what they had discovered were profound. Humans, the Deathworlders, were truly a paradox, burning energy at an extraordinary rate, thriving on movement and activity, yet vulnerable to the very systems that kept them alive. As the lesson ended, the students left the classroom with a new perspective on the humans they had once seen as strange and inefficient. Now, they understood that beneath the surface of their constant motion and caloric consumption lay a deep, evolutionary purpose. Humans had evolved to burn calories not because they were inefficient, but because they were built to endure a universe that demanded constant adaptation.